Now we're going to learn how to deal with radical equations, okay? So we're going to solve radical equations. You've done this in some part, previously, but we're going to add a little bit more to it. Before we start, okay, let's remind ourselves what the graph for y equals root x looks like. So remember, it just looks like this, and right, because the radicand can never be a negative number, okay? Not all solutions will work for this, right? Do you see how like the domain is restricted, right? So that's what we have to think about, okay? The domain is not all real numbers, so we always have to check for the domain. Okay. Okay. So let's solve some radical equations. So remember, the domain is only half of the domain exists, so we always have to check for extraneous solutions. So how do you solve radical equations? First, you want to isolate the radical on one side of the equation, if possible. Sometimes it is, sometimes it's not. What you want to do is you want to make sure on one side of the equation, the radical is either alone or there's only one radical on each side of the equation. Raise each side of the equation to the power equal to the root to eliminate the radical. Sometimes you have to do this more than one time. Solve the equation and then check for extraneous solutions for reasons I just mentioned. So take a look at this one. First, we isolate the radical. So plus 1 plus 1. The square root of y minus 1 is equal to 6. Now, this is a square root. That index is a 2. So I'm going to raise both sides to the power of 2. And I'm going to get y minus 1 equal to 36. So then y is equal to 37. And then you do want to check. Okay? To check, you have to plug your answer into either the original or the step right before you squared. If you plug it into the step after you squared, it's always going to work because you removed the problem, which was the square root. So we can so I'm going to plug it into, this step here. So the square root of 37 minus 1, is this equal to 6? And it is, so that is a solution. Okay? All right, let's do the next one. Now the next one, I have two radicals, right? It's fine as long as I only have one on each side of the equation. That's fine. So now right here, I'm going to square this and I'm going to square this. Okay. So when I square the left side, I just get x minus 12. When I square this side, remember it's the 2 minus x squared. So it's going to be, the trinomial. So it's going to be, okay, so you square the first, you get 4. You square the last, you get plus x. Then it's 2 times negative root x times 2, negative 4 root x. If that's something you don't want to do, then just write it out like this and FOIL. Okay? All right. Now, let's isolate the radical. So what I want to do is I want to subtract x from both sides. Oh, look, it went away. Subtract 4 from both sides. So I get negative 16 is equal to negative 4 root x. Okay, at this step, if you can divide both sides by a common number, you should. So let's divide both sides by minus 4. So I get 4 equals root x. Square both sides. So I get x equals 16. That's a pretty answer. So now let's check. All right? Let's check. So I'm going to plug it into the first step over there. So the square root of 16 minus 12, is this equal to 2 minus root 16? Well, here I get root 4. 2 minus 4. Does that work? No. So this is no solution. You see that? Even though you got a pretty answer, and you're like, oh my God, how cute, it doesn't necessarily work. That's an extraneous solution, yeah. Right? Because we squared, we got rid of the radicals, we removed that condition. So the math gave us an answer that would not have been there if the radicals never went away.
So that's why it's no solution?
It's no solution.
Only if the root 4 is negative 2.
Well, no, here you're saying on this side you have root 4, which is 2.
2 or negative 2, right?
No, just 2.
Oh,
just 2. Remember, we do principal roots. Just 2. Okay. So here I have, okay, I'm going to subtract the 1. So I have 3n plus 2 to the power of 1/3 is equal to negative 1. Now, this is an exponent of 1/3. So that's the same as a cube root, right? How do you get rid of a cube root? You would raise it to the power of 3, correct? Now, when it's in exponent form, you also want to raise it to the power of the reciprocal, 3 over 1. So this also to the power of 3. So now I have 2n minus 2 to the power of 1. Oh, 3n minus 2 equal to negative 1. So what's 3n equal to? Positive 1. So n is, no. Oh, no. Sorry. This is 3n plus 2. So 3n equals negative 3. N is minus 1. Okay, now, this is a cube root. This is not a square root. What is the domain for cube root functions? Everything. All real numbers, right? So for this one, there is no need to check for extraneous solutions. They will all work.
So why
okay?
Is it all real numbers?
Because a cube root, it's all real numbers, because you can have the cube root of a positive number, or you can have the cube root of a negative number. It doesn't matter, right? The domain of cube roots is all real numbers. Okay, let's take a look at the next one. So let's add 2. Okay, so now divide by 3, divide by 3. So 5y minus 1 to the power of 1/3 is 2/3. Now I raise it to the power of what? 3 over 1. So I get 5y minus 1 is equal to 8 over 27, right? Add 1 to both sides. So 5y is equal to 8 over 27. Okay, how are we going to add the 1? Plus 27 over 27. Correct. Now, I need to divide by 5, which is the same as multiplying by 1 over 5. So y is 7 over 27. Yes. Right? Yep.
What would you do if you didn't multiply? No, if you didn't put the exponent of 3. Like if you do 2 over like that exponent.
No.
To make it full.
No, because this isn't an exponent. That's the exponent, 1/3.
But are you multiplying it by 3, or are you?
You raise it to the power of.
Yeah.
Okay, now, those were equations. So remember, if you have an even root, you got to check for extraneous. If you have an odd root, no need to check. Now let's talk about inequalities. Okay, sorry.
I'll just do it one question.
So, okay. Now let's talk about inequalities. Remember, going back to even roots have restricted domains, right? So, if you have an even root, you have to first identify the domain. How do you identify the domain? You have to say when the radicand is greater than 0, okay? After that, you solve the inequality, and then you want to test values to check your solution. So there is an added step here, okay? So let's take a look at this first equation. I can solve this all I want, okay? But I have an added requirement now that whatever value I get, when I put it inside for x, that radicand can only be greater than or equal to 0. Okay? All right. So first, what you want to do is figure out the domain. So here's how we do that. You take the stuff inside the radical, that's the radicand, and you say that has to be greater than or equal to 0. Because it can be 0 inside, it just can't be negative. So now 3x is greater than or equal to 6. X is greater than or equal to 2. Okay, and I'm just going to let that hang there for a little bit. Now I'm going to come and I'm going to actually solve my inequality. Okay, give me a minute. I'm going to solve my inequality now. So I subtract 4. The square root of 3x minus 6 is less than or equal to 3. Now, just like before, I'm going to square. So I get 3x minus 6 is less than or equal to 9. 3x is less than or equal to 15. X is less than or equal to 5. Now, I have two situations here. On the one hand, let's go on a number line. On the one hand, this is telling me x is less than or equal to 5. My domain, though, is telling me, but it has to be greater than 2, right? Yes. So here is 2 greater than 2. So do you see how there is an and situation here, right? So then the final answer will be 2 less than or equal to x less than or equal to 5. Okay? This was the domain. The domain is greater than or equal to 2. So now the solution is the combination of the two. So here you got x is less than or equal to 5. Okay, but it can't be 0, it can't be 1, it can't be negative 3. There is an added restriction to it, right? Okay, all right, yes.
Why is the 3x for the domain part? Why is it greater than 0?
Because it's the integrand. What do we know about stuff inside the radical? It has to always be 0 or positive. Okay, so let's do another one. So for these, you first have to look at domain, then go on to solving them, okay? And if you forget the domain part, like if it's a 4-point problem, all I can give you is 1 point because you missed the point of the problem completely, right? Okay, so 2x plus 2 greater than or equal to 0. 2x is greater than or equal to negative 2. X is greater than or equal to negative 1. Okay, let's leave that there for a minute. Let's come back and solve. Minus 1, minus 1. Okay, the square root is greater than or equal to 4. Square both sides. 2x plus 2 is greater than or equal to 16. So what do I get here? 2x is greater than or equal to 14. X is greater than or equal to 7. Okay, now, this is telling you x is greater than or equal to 7. This is telling you x is greater than or equal to 1. You only take the portion that overlaps, the more restricted portion. So your final answer will just be x is greater than or equal to 7. Okay?
It's never or, it's always a.
Yeah. Right, because two restrictions have to be met. Okay, it has to satisfy this and this. Okay?
If the root is even.
Yes. Okay. So, let's take a look at another one. So here, okay, take a look here. For these two, the inequalities themselves were like closed circles, right? Less than or equal to, greater than or equal to. This one, the inequality is just less than. Fine. For the domain, however, that's irrelevant. For the domain, you still have to do 4x minus 4 is greater than or equal to 0, because that's a thing of its own. Okay, so when you solve this, x is greater than or equal to 1. Okay, so here, add 2. The square root of 4x minus 4 is less than 6. Square both sides. 4x minus 4 is less than 36. 4x is less than 40. X is less than 10. So let's see now. Okay, 10. Okay, less than, right? Open circle. 1 greater than, but it has a closed circle. So that is the inequality. So when I write the inequality, it's got to be 1 less than or equal to x less than or equal to 10. Okay? Okay, Livy and then Alec. Now I have 2 of them to check the domains for. So first, 2x plus 5 greater than or equal to 0. 9 plus x greater than or equal to 0. So 2x greater than or equal to negative 5. X is greater than or equal to negative 5 over 2. X is greater than or equal to negative 9. Okay, now to solve this, I need to take one of the inequalities to the other side. Remember, it's always more preferred to do that. So 2x minus 5 in the square root is greater than root 9 plus x. It's so much easier because then you're going to do, then it's just a mess and you have to do the squaring twice. All right. So now 2x plus 5 is greater than 9 plus x. So subtract x, we get x on the left side is greater than 4. Okay, now check out how cute this is. So I have here x is greater than 4, open circle. Then I have greater than or equal to negative 9, but I also have greater than or equal to negative 5 over 2, right? But what is the most restrictive? X is great. Okay, so now is it greater than or equal to 4? Just greater than 4. That's the one you take. Correct. It can't be 4 and it can't be anything under, but it could be 4.000000001. Okay? That's what that says. All right? Okay. So wasn't that a fun lesson? Isn't it like...
If the